In this session, we're going to talk about binary operations. Now, the term binary comes from the fact that the operation acts on two elements. In the usual operations, of arithmetics, you've got, the plus, you've got, the minus, you've got, multiplication. You also have the divisions. Now, these are some of the examples of binary operations, because when we choose any two numbers, each operation will generate a third number. Other examples of binary operations, we have the set union, and also the set intersection. So these are some of the examples of binary operations. For example, on the set union and the set intersection, if we say A union B is equals to C. Now, our U in this case is our operation. Then A and B, these are our elements, and they're generating a third number like that. And if it's just the same if we say A intersection B is equals to C. Yes, so our intersection in this case is the operation. But now in this session we're going to be talking about we shall use the symbol star. We use a star to represent a generic binary operation. So let's say for example we have let's say we've got S, and S has elements, let's say A, B and C. Now, how are we going to represent this in terms of the generic expression? We've said in this case our binary operation will be a star like that. So we'll say, let me say if we want to get A and B, so we'll say A, star B is a member of S. And how we indicate that in terms of set notation, or set in terms of set notation, we usually say A B like that. Then this one, to translate it to binary operations, we just say A star B. So let's look at some examples on how we solve binary operations. We're saying let the binary operation star be defined on the set R as A star B is equals to A plus B plus 2AB. Now we're told to find 2 star 5, and B was told to find negative 5 star 3. Let's start with the first one. We're saying 2 star 5. Now how are we going to do this? So wherever there is A, we'll be placing 2. Wherever there is B, we'll be placing 5. So in this case, we're saying this is equals to, we've been given A, plus B, plus 2AB. Now, we've been told that, our A in this case will be 2, plus our B in this case will be 5, plus 2. And we've said wherever there is A, we'll be placing 2. Wherever there is B, we'll be placing 5. Then 2 plus 5, that 2 plus 5, that is 7, plus this 2 multiplied by 5, that's 10. 10 plus 2, that is this 2 multiplied by 5, that is 10. 10 multiplied by 2, that is 20. So now 20 plus 7, or 7 plus 20, that is 27. So you found your answer for this one. Now let's solve the second one on this other side. Negative 5 star 3. So like we said, our first one will be A, our second one will be B. So again we're saying it's A plus B, plus 2AB. So our A in this case we're saying is negative 5, plus our B in this case we're saying is 3, plus 2. Our A we said is negative 5, our B we said this 3. Then we simplify. Negative 5 plus 3, that is negative 2. Let's say now you are multiplying 2 minus you're multiplying 2 and negative 5, that is negative 10. Negative 10 times 3, that is negative 30. So you have negative 30. Now negative and the negative, when the signs are different, you're just adding. So in this case, we've got negative 32. So you've simplified this one. So you're just replacing the numbers they've given you in the operation. Now let's look at some of the general rules that you need to consider when you're doing binary operation. So the order of A and B. The order of A and B really matters in terms of binary operation. It may be very important because if we say A star B, this may not be equals to B star A, because the order really differs like that, and it's really imperative to consider the order. Now let's talk about some of these rules. That you need to understand. There's a rule of commutative. Or let me say the commutativity law. Now in this law, what are we talking about? If you've got A plus B, is it the same as B plus A? That's what we're talking about. Is 8 plus 5 the same as 5 plus 8? If we say 8 plus 5, we are getting 13, right? Is equals to 13. So we find that the operation plus really works if these two numbers are the same and they are following each other. Then what about the operation multiplication? What if we say we have A multiplied by B? Is it the same as B multiplied by A? So let's say if we've got let me say we've got 3 multiplied by 2. Is it the same as 2 multiplied by 3? So in this case, you have 6 is equals to 6. So the multiplication sign or operation also works if the numbers are not interchanged. Now, however, we must make mention that the operation minus is not commutative. The operation minus is not commutative. So what are we talking about here? What if you have, let's say you have a situation, let me say you've got 8, the same example that we use, 8 minus 5. Is it the same as 5 minus 8? 8 minus 5, that is 3. And when we say 5 minus 8, that is a negative number. So you see that these ones are not equal. Therefore, the minus sign is it's not really like it's not commutative. It's not commutative. Then what about the set union and the set intersection? If we say you have A union B, okay. If you say you have A union B, is it the same as B union A? And if we say also on the intersection, if we say A intersection B, is it the same as B intersection A? So even these ones you find that these ones are also commutative. Now let's talk about another law that we can consider. This will be our last law. Let's say you have what we call, there's this law which is called the associative, or let me say the law of associativity. So now in this law, what are we considering? If all the elements are triple, they are aligned in a triple line. Let me say if you got A star B star C, is it the same? Are you going to get the same answer if you say A star B star C. So now in this law, just to make it quick, in this law we find that addition and multiplication are associative provided these numbers are the same. If you've got 1 here, you've got 2, you've got 3, would it be the same if you say 1, 2 and 3? Let's try. We're saying addition and multiplication are associative. Let's just try the addition one. If you say 1 plus 2 plus 3, is it the same as if you say 1 plus 2 plus 3? So say 1 plus 2 plus 3, that is a 5, is equals to, you've got 1 plus 2, that is a 3 plus 3. Now 1 plus 5, that is 6. 3 plus 3, that is 6. So you're able to see that addition is associative. Same, this also applies to multiplication. However, I must make mention that subtraction and division are not associative. So in this session, that's what we're just talking about binary operation, and I'll see you in the next session where I'll talk about questions and exam questions. Thank you very much.